Hi there! You might be wondering what I'm doing over at the Collingwood Pier. I just thought this was, aside from the dramaticness of it all, I thought this was a great place to start on a couple topics that I wanted to touch on, and I think we're gonna have a lot of fun with this. So, as you can see right here, there's a lot of water. And this water is actually home to a lot of different species. It's home to all sorts of different ecosystems, and it's also just one massive ecosystem. Now, of course, this ecosystem, it's experiencing change all the time. And one of the biggest factors to this change is, unfortunately, pollution. Now, of course, pollution, it comes in many different forms. It can come from the sky, it can come from landfills, but most of it comes from us humans. Now, an ordinary citizen, we might not contribute as much as we think and what maybe the news might lead us to believe. Of course, there are bigger factors like massive industries, celebrities, but still, we do have some responsibility for this. Now, I just want to talk about a couple different topics, and we're going to start off with one of the big ones, one of the big buzzwords we're used to hearing all over the place. I want to talk about climate change. Here we are, we're at just a little bit of a different location, and as you can see, there is all sorts of different things going on in the background. We have the mountains, we have the beach, we've got these beautiful rocks. Now, this ecosystem in particular, being just the bay, what we see is a lot of different pollutants coming in from sources that are actually quite visible, but really what I want to explore is more specifically the chemistry behind it all on a microscopic scale, So over here, around this area in particular, there's all sorts of things happening in terms of boats, people, other pollutants just seeping in from people littering maybe. This is a huge place for teenagers. We all love the pier, but what you can't really see is what's actually happening on a deeper scale. You see, we live in a massive world, and it's a world of perpetual change, and that can be anything from the tide, the setting sun, seasons even, the ones that bring us skating, skiing, summer fun. We all love it, but it's at risk, and it's at risk of great change, and it's driven by primarily human-made factors that are almost completely within our control. I'm gonna go out on a limb and assume that you probably know a little bit about climate change. You know, the thing that we all say is gonna bring temperatures up, the seas are gonna rise. It sounds all dramatic, but it is true. And it's a massive problem, and if we don't deal with it, well, something bad's gonna happen. If you look around, it's quite apparent that things are changing. There's green grass, and it's mid-December. The snow's melting. We had freezing rain and thunderstorms. It's not making sense, and things are gonna keep changing. I wanted to talk about specifically something called the greenhouse effect. Now, the greenhouse effect, again, is definitely something we've all heard of. I'm sure some of us have some basic ideas, but we also kind of had this falsity that maybe it was being better, maybe it was changing. And while, yeah, the governments are trying to do something, a lot of us probably don't know about it. But did you know that there have been massive conventions about this sort of thing all over the world? Massive multinational companies, massive multinational treaties being signed, and we're not really aware of that. It's something very interesting, and it shows a lot about what the common person might not or know about this matter. The greenhouse effect, it's been something that's kind of been villainized, because why not? It's a big buzzword, everybody's scared of it. You have some people all educated on it, some people that have never even heard or thought about the earth warming up. And honestly, some people don't know that without it, we wouldn't be able to live. Like, quite literally, it is one of the primary reasons life is being sustained here on Earth, because without it, the temperature on the planet would just be unsustainable, uninhabitable. And yeah, while that's a good thing, now we have the temperature rising almost 2 degrees Fahrenheit since the 1850s. Of course, you gotta take into comparison the fact that over the millennia, the temperature on Earth, it's changed quite dramatically. Tens, hundreds of degrees warmer, cooler. But why is it such a big deal? It's because that was over thousands of years. That was over hundreds of years. It doesn't matter, because in 100 years now, we almost have ice caps melting. We have the Arctic flooding. We have seas rising, and that's a huge problem. And there's lots that play into that. Let's explore some of the chemistry. The greenhouse effect, in simple terms, is what happens when we have the sun's energy beaming down on Earth, and the Earth's atmosphere, full of gases, it traps that energy. As vapors get heated up, they float up, they move around, but they still get trapped. Now, the thing is, these vapors there's a specific name for them. You've probably heard of it. They're called greenhouse gases, and that kind of makes sense. Now, do you know what a greenhouse gas is? Maybe, maybe not. Some examples that most commonly are spoken of are either carbon dioxide, which is something we breathe out, carbon in the air, it's what our cars produce, and then the other one, big one, is methane. Now, methane is cow fart specifically. It's what the gas that is released from a lot of organic decomposition. Now, some of these things, they're quite produced in moderation. Now, organics and all that, they're just byproducts of living, of ecosystems doing their thing. That's not a big deal. The big problem is corporations and industrialization of all over the world. In our attempt to create global domination, and we've tried to industrialize every square kilometer that we can all across the world, we've created a massive problem for ourselves. Now, this excess in sun radiation and warmth being trapped in the atmosphere, it's causing the passive temperatures of the Earth to simply warm up. And while it might not seem like a big problem, and you might be wondering why, let's just say, well, that's why. Unfortunately, climate change isn't the only thing us humans have massively screwed up on. Now, there's another thing, quite similar, but it's different in its own respect, and it's called global distillation.
Now, the one I want to focus on is called global distillation, also known as the grasshopper effect. You see, it's a very interesting mechanism in which you have different chemicals being emitted in the air. Now, these chemicals are in a vapor form. They go into the atmosphere, and then what happens is they go up and they travel due to their density to the North or South Pole. And then what happens is, just because of the colder climates in those regions, especially even on mountaintops, you have those chemicals condensing and falling. Now, this can have all sorts of different effects on the climate. They can have different effects on the local ecosystems. And I want to talk about that, but I want to give you an example specifically if it's not understood. You see, the reason I'm recording in a little bit of a peculiar spot is it's nighttime, which means if I turn the lights out, I take a flashlight and I place it very specifically here. You might have seen a globe. So this globe is going to represent the Earth, obviously, and I'm going to explain a very simple concept with some water. Basically, if you want to look at it, the light, by the way, is just for the concentration of the water vapor. We're going to pretend that these are our chemicals. If I take it and I spray it, what happens, you can see how it goes. It comes up to the poles. As it comes up to the poles, it begins to fall. And as it settles, it begins to condense. And the regions primarily affected are, unfortunately, the Arctic Circle and further south. Of course, it's also interesting to note that places with higher altitudes, colder climates, will also experience global distillation just due to their nature. Now, it's actually very interesting to see how global distillation isn't really the bad guy in this scenario. It's actually the byproduct of the mechanism. You see, you might have been wondering what chemicals I was referring to, as I was intentionally trying to be a bit vague. Let me introduce you to something called persistent organic pollutants. Now, for short, we're going to call these POPs for the sake of the video, but they're also not to be confused with PFOs, also known as perfluorooctane. We're going to begin to explore POPs, and they're actually very, very interesting. But there's 12 I want to focus on called the Dirty Dozen, and I think this is going to get real cool. You see, the Dirty Dozen is an infamous bunch of chemicals that are organic compounds. They're created to serve various purposes, such as herb, fung, pesticides, such as the well-known DDT. Now, these have been banned because they're very dangerous, and we'll talk about why. Here I have two different types of pesticides. These are for the caterpillars that recently have destroyed a lot of the trees in our region in Ontario. Now, we can actually explore many different ways that pesticides benefit us while not creating lots of damage for the environment. It's very interesting. Now, also similar to the POPs, but not to be confused with them, is PFOs, or perfluorooctane sulfonates. PFOs are very, very interesting because they're actually very, very similar to POPs, but they're different in their own regard, and we'll talk about them on a little bit of a separate note. Now, before getting deeper into the dirty dozen, I actually want to explore what a POP really is. You see, take a hydrocarbon. Pretty simple, pretty straightforward, very well understood. Now, in the 1900s, scientists were discovering that they can take these bad boys and modify them kind of however they please. And with that, they will experience different properties and thus different uses. You see, POPs, they're very, very important to the economy and to us as a civilization. They've allowed us to develop very significantly plastics, pesticides, but unfortunately, they come with some pretty nasty side effects. You see, POPs, they're actually intentional, and some of them, well, not so much. They can be used in industrial settings. They can be used particularly in agricultural settings where we get our very, very infamous DDT. And they act as pesticides, herbicides, and fungicides. And then you have your other more niche ones, which are actually byproducts of different chemical reactions and are typically waste. Now, scientists discovered that if they halogenate this molecule, you take it and add a halogen to the end, or wherever you please, you can actually change the properties of it. You see, the problem is chlorine is very reactive. In fact, it's actually very, very prominent in our society just because of how many uses it has. But in this case, with the POPs, they're very, very dangerous. Let's use DDT as an example. DDT is a pesticide. And as a pesticide, it was very, very widespread. It was spread everywhere. And it comes with some very destructive side effects. And while, yes, it is toxic and a carcinogen, it's also very prone to something that a lot of PFOs and POPs are prone to, called biomagnification. Biomagnification is a really, really big deal because you have a contaminant and you have something that is going to come into contact with that, whether that be a primary consumer, whether that be a fungi, whether that be a larger animal, wherever it is in the food chain, if it's going to be consumed, it's going to move up. I want you to imagine this. You have minnows. They are contaminated with the rainwater runoff of a farm field. What happens is, unfortunately, those minnows are in the water. They become contaminated with trace amounts of DDT. What ends up happening as you move up the food chain, the next thing that comes along, it's going to need more of that energy, so it's going to have to eat more of the food. So what happens is your DDT becomes more and more and more concentrated until eventually you reach the apex predator, which unfortunately tends to be us. And this is why it's so dangerous. Now that we understand POPs, let's look at our next topic, PFOs. As previously mentioned, their long name is perfluorooctane sulfonates, but we're also going to be talking about all per and polyfluoroalkyl substances, which are thousands of human-made organic compounds that fall under the family term called PFASs or PFASs. PFASs are actually very commonly present in many different industries, all the way from aerospace, the automotive, textiles, and even utilities, due to their many very interesting and significant properties, such as some of them being very stable or unstable, and some of them repelling water. Now, while there are many benefits to PFOs, they come with a cost. All of them are very, very toxic and very much dangerous, especially when present in food, air, water. They're very easily contaminated with other things. And you see, what happens is you have these compounds, like POPs, that are highly toxic, and due to their instability, they react with many different things. Unfortunately, PFOs are also the perfect candidate for bioaccumulation, and that is what makes them so dangerous. And while it's interesting to look at bioaccumulation on its own with PFOs and PFASs, because yeah, it's extraordinarily important that we understand that when contaminated in an ecosystem, it moves up the food chain rapidly and very potently. The problem is, especially with PFOs and PFASs, is that their bonds are some of the strongest found in chemistry. Now, this is due to PFOs being created by carbon-fluorine chains. You have a carbon and a fluorine chain. And this is very important because they actually are very, very strong when paired together. Now, due to their intramolecular forces, they want to stick together. And in nature, there's very few circumstances in which there's going to be an opportunity for them to separate. And that is why they're so persistent. They kind of just exist forever. And even while they're reactive, it's because they're together. These together, very hard to be separated. PFOs and PFASs are very, very similar to POPs in general. In fact, there are actually many qualities that they share. They're in general large, persistent chemicals. And some of them are very well known and some not so much. And this gives them many various qualities that are both harmful and dangerous. This can cause bodily harm, such as mental illness, physical damage, and unfortunately, disease and bioaccumulation, thus requiring an international effort to regulate them. Now that we understand more about what POPs, PFOs, and PFASs are, I wanted to talk about what the governments and organizations of the world are actually doing in order to contribute to solving the problem. You see, unless you were a hairspray fanatic from the 80s, or a farmer or a politician, you probably haven't heard of the Stockholm Convention. Now, the Stockholm Convention is where there have been massive multinational treaties of countries coming together and agreeing that we need to do something. It's aiming at controlling, regulating, and restricting the production of and use of POPs and PFOs in order to prevent their extremely harmful effects on the ecosystems and human life. This is actually very similar to the Montreal Protocol, which is kind of what the Stockholm Convention was based off of, in which you had massive, massive treaty signed of almost every country, but they all agreed, we need to do something. And so what happened is they looked at propellants found in aerosol cans, due to them being much more popular in the 80s, especially from air conditionings and other refrigerants as well. When they were leaked, they put holes in the ozone.
Well, now that we know a little bit more about these so-called, quote, forever chemicals, let's explore more of what they are and the effects that they have and why they're such a big deal.
The Government of Canada has recognized the impact of POPs and PFOs and has implemented measures to prevent them from having increased impacts on the life in our country. But that doesn't mean that there hasn't already been damage. The Canadian Arctic is home to many Inuit and other natural life, and has unfortunately been widely contaminated by these harmful chemicals just due to the pollution and global distillation alone. Doesn't involve all of the other horrible things that have ended up near their waters. The Inuit diet consists primarily of fish and other seafood, which not only has been a source of heavy metals such as mercury and lead, but also contaminated with POPs and PFOs. Now, as a result of bioaccumulation, there's been a massive increase in the ingestion and chemical pollutants, and this has resulted in a wide variety of issues caused by these contaminants, such as multiple organ failure and function, increased rates and severity of various cancers, pregnancy complications, and many other major health issues. And yet the worst part is that the people most exposed to these harmful chemicals are already the most susceptible to harm from them due to difficulty reaching healthcare and the ability to prevent contamination, as their diet is quite strict to the northern waters of the Arctic and prairies. In an effort to prevent further complications from these harmful chemicals and to further understand their effects on the northern ecosystem, it is a possibility that encouraging northern people and Inuit to pursue answers and even study and research this chemistry themselves might be necessary as a result of overwhelming studies being conducted by people from the south who are most likely motivated by large corporations or even their own study paper, not in benefiting the livelihood of these nearly exclusively affected by large accumulation of POPs and PFOs such as the Inuit people.
Now, putting all of this negative stuff aside, here's the deal. I personally have great faith and hope in the spirit of humanity to come together and collaborate on a solution in the form of huge, massive multinational treaties, massive collaborations between governments and organizations. I think we can create a massive difference in dealing with these PFOs and others. Now, while persistent organic pollutants are, well, unfortunately persistent, that means they're here to stay. But that doesn't mean we can't solve all of the negative problems that we just talked about. Personally, I have great faith and hope in the spirit of humanity to come together and solve these issues, whether that be in the form of massive multinational treaties, hopefully unanimously, such as that of the Montreal Protocol, where everyone decided to create a massive difference. Or whether that be through, unfortunately, volunteer organizations that might get left with whatever scrap we can produce. And at the end of the day, I think humans will always come out on top and we will solve our problems, because what other choice do we have? Hopefully, in the next 50, 100, 200 years, we won't even have to talk about this sort of thing. These could all be dealt with, whether that means they're all completely eradicated or regulations are strong enough that they're not a problem anymore. We'll find out, but let's hope for the best.